Hello and welcome to lesson 2.6 over algebraic proof. This is the first of our lessons over the proof process, and in geometry we do a lot of proving that statements are correct, or proving that they are what we are setting out to say they are. And so this is the first chance we have to try and do that. We are doing lesson 2.6 before we do lesson 2.5. So hopefully you've already done the vocabulary for lesson 2.6, and you've already kind of read through that lesson and done the introduction to 2.6 worksheet, and we're ready to start the notes. Alright, we're going to kind of ignore where it says what we used to be able to do in the then box, because that actually refers to lesson 2.5, which you will recall we haven't done yet. So we're actually going to get to that next lesson, but this is what we're going to do today. We're going to use algebra to write what we call two-column proofs. We're going to use properties of equality to write geometric proofs also. Your vocab includes these words: algebraic proof, two-column proof, and formal proof. And then we have the following chart in your note packet. Now, you have not filled these in yet, but I want to show you something specific about how we write these things in our vocab notebook and how we put them in the notes. Alright, in your vocab notebook you should have done lesson 2.6 and have written down these three vocabulary terms. Now after that we have some special vocab that are called properties in this lesson. So after you've done these three vocab terms under Roman numeral 1 vocabulary, underneath that I want you to put Roman numeral 2, and I want you to write properties, postulates, and theorems. And we are going to fill in those kind of vocabulary terms in this spot. Now you'll notice that there is a table on page 136 of your text, and it is the table that I'm getting ready to show you in your notes. In the notes page you picked up in class, the half on the right is actually blank, and you don't have to necessarily fill that in the notes if you've copied the table down from page 136 in your vocab book. Otherwise, you can follow along in the video and copy them in your notes. But you do need to have them filled out in this vocab book. I think the first property listed for you is the addition property of equality. Okay, so you'll write that, and then you'll write what that property states on the right. And then you'll list all your properties in that section. So that's how we put together our vocab notebook with properties, and we'll eventually get to what postulates and theorems are. And here's that table I was referencing. Again, you can find this on page 136. These are the properties we talked about. The addition property of equality, that name of that property is for when we are solving an equation and we add the same thing to both sides. The subtraction property of equality is when I'm solving an equation and I subtract the same thing from both sides. Multiplication property of equality is when I multiply by the same thing on both sides. Division property of equality is when I divide by the same thing on both sides. Then we have the reflexive property, and that is where something equals itself. One value equals itself, like 5 equals 5, or 2 equals 2, or x equals x. It may seem like that goes without saying. It may seem unnecessary, but it will come in handy when we are working on different things in our proof. The symmetric property of equality is a little bit different. That says if A equals B, then B equals A. The transitive property is one we will use quite a bit. And here we have, if A equals B and B equals C, then A equals C. And what that allows us to do is to chain our logic together. That if we say, if one thing leads us to another, then that thing leads us to a third thing, we can say that the first thing led to the third thing. Then we have what's called the substitution property, which allows us to say that if A equals B, we can replace A with B in any equation or expression. And the distributive property, which you guys all know about. I can take A and multiply it by B and C to get this. So let's go ahead and take a look at our first example. In example 1, we have this equation. This is our beginning part of our algebraic proof lesson, is just to solve an equation and justify each step. And this is how we do this. We write out each step of our solving our equation process, and then we write the property that allowed us to be able to do that. Now you'll notice in this first step that the first thing we need to do is write the original equation. If it's not written on your paper already, you'll need to start by writing that. So we have our original equation, so we write that down. Make sure you copy it down, and then the reason or the property we can put here is just that it's the original equation. Everything we write on our paper has to have a reason when we do a proof. Then the next thing we're going to do is use the distributive property to distribute 2 to the 5 and 2 to the negative 3a to get 10 minus 6a, and then negative 4 to the a and negative 4 to the 7 to get negative 4a and negative 28. And that's how we use the distributive property. Then the next thing we'll notice that we need to do is we've got like terms here, negative 6a minus 4a and 10 minus 28, and if I simplify or combine like terms, okay, I can just get negative 18 minus 10a, or we might write negative 10 minus 18, and then the side is still 92. Now the next thing we need to do is to get the a by itself, so I'm going to add 18 to both sides, and anytime I add the same thing to both sides of an equation, that property is called the addition property of equality. And so you'll see me write POE instead of distributive POE would be property of equality. So addition property of equality can be just addition POE. The next thing we need to do is to take this and divide both sides by negative 10. When you divide both sides by the same thing, that's our division property of equality, and that is the answer. So doing an algebraic proof is just solving an equation but justifying each step, which you guys are used to doing. So let's take a look at applying this to what we call literal equations. A literal equation is any time we use an equation that has more than one variable to represent something else, and a lot of times our formulas can be considered literal equations. This is the distance an object travels for a certain amount of time called t. Alright, and so our formula for distance is d equals 20t plus 5, but if I want to know what it is in terms of time, this is the equation I would use. We're going to write a 2-column proof, or just an algebraic proof, to verify this conjecture. So we're going to start with this given formula solved for d, and we're going to resolve this equation for t. And solving an equation just means getting whatever variable you're talking about by itself on one side. So I want to work with this equation and get to this one, and so here's how we do that. The idea of doing a 2-column proof is that we set up all of our statements of our proof and then give a justifying reason for each one. We always want to start with the given information and work our way down to what it is that we're trying to prove. So if we're given this original equation, d equals 20t plus 5, we can say that that is given. That's the given information. I can use the word given as a reason in a proof. I cannot use the word prove as a reason in a proof. We know that we're going to get down to this statement. So the fourth statement is going to be this. And then to get there, we have to start with this and look at how we can start to get t by itself. Well, the best way to start by getting t by itself is to subtract 5 from both sides. Now when I show this work here, I don't have to justify showing that work. I can just show what I would get as a result. If I subtract 5 from both sides, you get d minus 5 equals 20t. And that was the subtraction property of equality. And I can use POE to mean property of equality. Then the next thing we need to do to get t all by itself is to divide both sides by 20 to undo that multiplication. Again, I don't have to justify showing that work. I can just show what the result is. It gives me d minus 5 over 20. Since I don't know what d is, I can't simplify that anymore. And on this side, the 20s cancel and we have just t. Again, that was the division, and I can abbreviate div, property of equality. Now, this you might think, well, that's done. We don't have an extra step we need to use. But this doesn't look exactly like this. In order to get the t on the left side and everything else on the right, we have to use another one of our properties. This is the property that says if a equals b, then b equals a. That is our symmetric property of equality. And you can abbreviate that as well. Alright, let's have you try one of these on your own, and you can just fill in the blanks on a lot of this one because I've done part of it for you. But let's say we started with the area formula of a trapezoid and then solved that formula for h. So you want to get h by itself. So we want to start with this and get to this. And so you need to set your proof up like this. write a column for your statements, a column for your reasons, and that's been given to you in the notes, and we just need to fill out the appropriate things. These 3 statements are missing, and these 2 reasons are missing. And so we need to start with this and get to this. Why don't you take a minute to try and fill in these blanks with what needs to go where, and check your answer. Alright, pause the video if you need more time, but this is what we should get. Here's what we should have. Our first statement is always the given, so we're just going to write that in the first blank, and the reason is that it is given to us. And so the first thing we should do to get h by itself is get rid of this fraction. And I know that I have to do this first because the first reason they give me after given is multiplication property of equality. This tells me that what I get next is a result of multiplying both sides by the same thing. Well, if I multiply by h, that gives me h squared here, and that doesn't help. So what I need to do is multiply by something that cancels out 1/2, which is 2. So you multiply both sides by 2, and therefore we get 2a equals parentheses b1 plus b2 times h. Then the next reason tells you how to get this. So I look at what I did to this to end up with this, and that was to divide both sides by that b1 plus b2 quantity. If I divide both sides by that, these cancel and we just have h. And so that's the division property of equality. When you divide both sides by the same thing, you get the division property of equality. And then lastly, we use the symmetric property again to turn this around so that it is in the right order. Alright, the last example we have here is using what we call a geometric proof. We're going to use geometric concepts to identify and work out a proof. Here's what we are given. We're given that angle A is congruent to angle B, and that the measure of angle B is twice the measure of angle C, and that the measure of angle C is 45, so we should be able to figure out that the measure of angle A is 90. Now most of you could probably look at that logically and figure that out. Remember, this means that these are congruent. It doesn't say their measures are equal, but that's what that means because we know the definition of congruence means 2 figures with the same measure. So what we need to do is start off with our given statement and get down to our prove statement. So the first thing we do is write the given. So that reason is that this is all given to us. And then the next reason tells you how to get this statement here. That reason says definition of congruent angles. The definition of congruent angles tells us that if 2 angles are congruent, then their measures are equal. Well, I'm given this part of that. Angle A and angle B are congruent, so that must mean by their definition that I'm supposed to conclude that they have equal measures. Then I can say that the measure of angle A equals 2 times the measure of angle C. Well, that looks a lot like that statement, but instead of measure of angle B, I have measure of angle A. But those are equal. Since these are equal, I can take the measure of angle B out and put in the measure of angle A. That is the substitution property of equality. And then I'm going to use substitution again from this to get this. Well, let's look at what we have. We know that the measure of angle C is 45. The measure of angle A has been substituted in there, and the last statement talks about the measure of angle A, so I probably start with the measure of angle A equals 2 times, instead of the measure of angle C, we put in what it is equal to, 45. And then all we have to do to get from this statement to this one is to simplify 2 times 45. So our reason is just simplify. Alright, that brings us to the last part of this proof. What I want you to do is to try and put this proof together all on your own. Notice we are given congruent segments and we're proving something about a length. So at some point we're going to have to use the definition of congruent segments, and I've given you how many steps it should take. You know that the given information should go in the first blank. And that our last statement should be that RS equals 12. Go ahead and try and prove that, and then we'll check our answers in class when you get back on block day.